Hello, welcome back to our course on data structures and algorithms. Today, I want us to look at making a list that can hold something besides just ints. We could rewrite the entire class. We've made an array list that can hold ints. We could do something similar to hold doubles or maybe strings. But what about birds or motors or students? I mean, there's millions of different classes. And in fact, what if it's a class that someone that wants to use your lists made themselves? Well, the answer to this is to use what are called generics. So in a project called lists, I've created a class called generic list. And you can see here it is. There's that generic tag. And I'm using the capital letter E. You'll also see the capital letter T a lot. This is it right here. And what we're saying is that we're going to not say what type of variable we're holding. We're simply going to use the letter E. Then when users of our list instantiate it, they will tell Java what they want it to hold. And I'll explain more on that as it comes. So what I want to do is I want us to make an interface first. So let's go ahead and do that. So I'm going to make an interface. And I want my interface to be called, let's call it, we could call it list. Of course, Java already has a pre-made list interface. That could cause some name collisions later. Maybe we can call it, how about my list? All right, so my list. Let's make an interface. So what is an interface? An interface is simply a listing of the methods that we plan to use in our class. And then we can give people the interface and tell them what all is in it. So the interface is just a description for how this class works. It's a lot like the documentation. So here are the methods I want us to use in this interface. Public interface, oops, don't need to capitalize that. Public interface, my list. And this interface is going to take a generic as well. And let's take a look at what methods that we would like to have in it. Well, I would like to be able to add. And so you'll notice that what I'm going to put is add and then E. And that E is saying that will be whatever the user puts in this E here when they instantiate it, it will go here. So if they put string here, string will go there. There is one little requirement, and that is that the E has to be an object. So we're not going to store ints or doubles, but we can store integer, and we can store capital D double. We'll just have to use the wrapper class. Not a big deal. All right, I got a few more other methods I want us to do. All right, index and all right, so that method is going to add at a specific index. And in fact, let's go ahead and make some of our Java documentation right here. And I'm not going to add too much detail. You can go back in later and make your Java docs a little more useful. Adds data, adds an item to this my list. And it does take a parameter, and that is data, the item to be added. All right, and then what we're going to do is just do the same thing here. All right, so this is going to add an item to this my list at index given. So we got two params. We have at param index, the index where the item is inserted. There we go. Let's add a little bit more description. It adds an item to this my list at the index given and moves every item at that index and after back one index. All right. That's a pretty good description of how that's going to work. All right, let's take a look at what else we're going to do. Well, I'd like to be able to make my list. Let's make sure that we can remove. So the remove method will take in an index, okay? And it will return what used to be there. Removes the item at the given index and returns it. So it takes a parameter of the index to remove and return from. And it also has a return statement. It's going to return the item at the index. All right? Okay. And notice that each one of these lines of statements, they are by definition public. So I could write the word public here, but I don't have to. Notice they also don't have curly braces, they just have a semicolon because they are just an interface. All right, I also would like to be able to describe the size. All right, so at return the size of this my list. And remember, Java docs oftentimes seem a little bit redundant, and that's okay. Yeah. Just moving some windows around here. Okay, so this is going to return an int. And that's all that one's going to do. We also want to have a method for setting. And it will take in an index, and it will return data. It will return what used to be there, I should say. All right, so this is the set method, and it will return, it will, let's say, replaces the item at the given index with the given data item. All right, and returns the item there, or the old item at that index. So we're going to replace the item at the given index with the given data item and return the old item at that index. So we're going to take at param, which will be the index, which is the index to set, at param data, the data item to add, or the new data item, and at return the old data item. All right, and one more. Let's make sure that we can do an index of. Returns the index of the object parameter. Of the object here. All right. So we're going to at return, no, at param, the object to search for, at return the index of the object, or -1 if not present. So that's int index of, and we're actually going to use opt so that people don't have to send us e. We'll just search for by object. We'll deal with that issue when we get there. All right, I think that's a good start. We can always come back and add more later if we want, but we have a nice description of what we want it to do. Let's see here. There it is. Okay, cool. There are a few things that could happen here. Maybe we should go ahead and add just a listing of some of the exceptions we might throw. For example, we might throw this exception. It throws index out of bounds if index is less than 0 or greater than, or index is greater than size. Now remember, you can add at the size. Now that will not work when we try and remove, because it has to be something already in the list. So greater than or equal to size. And let's see here, we might, we could also get that right here as well. Okay, let's see, anything else? No, does not look like it. Well, there is actually another issue. We could try and add an item that cannot go in this list if it's not the proper data point. For example, if we are setting it to be strings and we try and add something that's not a string, we could get a different error. But we'll deal with that when we get to it. So we might come back and add some more things that can be thrown here. Okay. So we've got public class generic list. I'm going to add that it's going to implement, we implement interfaces. Just remember II for implement interface, II. Implement my list of type E. Okay, perfect. All right, now let's see here, implements, there we go. And we should get a warning saying, oh, look, we don't override that method. Well, that's okay. We're about to do that. Okay, so first thing we're going to do is we're going to make our class, our fields, our instance variables for our class. So we're going to have a size variable, and we're going to have an array. But this time the array is going to be of type object. So let's talk about why that works. Object is the superclass of every class in Java. Every single class subclasses object. That's part of the reason why we can't use primitives, though. Int is not an object, but integer is. So as long as I make the array of type object, there's nothing I can't put in it. All right, so we'll say public generic list for our constructor. And we'll go ahead and make our array equal to a new array of objects, and I'll just make it of size 5. And earlier we were making a constant so that it can be set. We'll just leave it at size 5 and just type it in there right now. That's fine. And our size is 0 upon instantiation. All right. So the first thing we want to do is we want to add that add method. So public void add e data. So how is this going to work? All right. Well, remember, we need to have an expand, right? So if the size of our list is equal to the length of our array, then we don't have enough room. So we'll expand. After we've expanded, though, we simply take our array at index size and we assign data to it. I don't know what type of variable data is. It's a variable type E, which is just a placeholder. If the list was of type bird, then this would be a bird. But whatever it is, it will be an object. So it'll fit in there just fine. All right, and we need to make sure we increase our size or this really won't work well. All right, let's go ahead and write that expand method before we get. Notice that I'm making it private. I don't want people looking at it or trying to call it. It doesn't make sense to try and call it. It's just a private method that I use. So we're going to make an array of type object called temp. And I'm going to make it the current length times 2. Then we'll use a loop. Temp I will equal array bracket I. So we're assigning what used to be there. After I've done all that copying over, I'm going to change what array is referencing. I want array to reference my new variable of the pimp, and that should be good. All right. So we've got our add method should work fine. Let's go in here and let's throw in our add at index. All right, well, how does this work? We're going to be inserting it at this index, and then everything that used to be there is going to have to be moved back one. So first thing I need to do is see if I need to expand. So if size is equal to array.length, well, then we need to expand. All right. Then what I'm going to do is I'm going to say for int I equals index plus 1, and I less than, sorry, I greater than, I'll also do that. You know, okay, actually, you know what, I think for a second. This is not how I want to do it. I want to start at I equaling to the size. We know that we can write at size because we just expanded if we couldn't. So, well, I'm going to start with I equal to size. I'm going to keep doing this while the I is greater than the current index, and I'm going to decrease that I. And what I want to do is I want to take my array, bracket I, which remember, we're starting one cell after where our last item is. Because we're starting at size, and our last item is at index size minus 1. So I'm going to take it and I'm going to copy over what's one before it. And we're going to keep doing this all the way down until I is equal to index, because when I is equal to index, we'll stop. So this will copy over I minus 1 is the index we're inserting at. All right, so I've copied it all over. Now I'm just going to write over the value at index with the value at data. All right. Okay, next we need to do remove. It returns an E. All right. So now we've learned to deal with generics for the first time. We really need to think about it because we're promising to return something of type E. I don't want to put in birds and get out object. I don't want to put in motors and get out object. I want to get out the type that I put in. So what I'm going to do is I'm going to say E, and I'm going to put, this is the old data that we're moving, so I'll just say data is equal to array bracket index, but I need to cast it. So we'll do that right there. Okay? Perfect. So it's going to cast it as type E. All right, I just realized that in our last method with index, we forgot to check and see if that index was appropriate. If index is less than 0 or index is greater than size, we need to throw a new index out of bounds exception. And I'm just going to leave this blank for now. You can fill this in with some meaningful string statement. Exception. There we go. All right, so yeah, I definitely, and I need that as well down here at remove. We can't remove something out at a wrong index, and this needs to be greater than or equal to size. All right, so I've stored the value that was there, and then what I'm simply going to do, after you remove something from a list, everything's going to slide forward to replace what you just pulled out. So, for example, you know, like if I had a list A, B, C, D, E, F, G, H, I, J, K, if I remove the E, everything needs to slide to the left. Okay? Just like that. So we're going to say for int I equals the current index, I less than size minus 1, I plus plus. I'm going to say array bracket I equals array bracket I plus 1. All right. Now, if we try and remove from the very back of our list, this will never happen because if our index is the last index is size -1, so that won't run this at all. That's okay because when we remove from the back, we decrement our size. So we just have that, it's just removed there at the end because it's no longer accessible to us. All right, so we've got remove now. That's good. We're making a better list here. We need to make sure that we can tell our users how big our list is. Make it public. Public int size. Just returns the size of the list. All right, public set. So this thing here is kind of like remove, but instead of looping back and scooting everything over, we replace it. So if our list again is like this series of letters, if I was to set index 2 to the letter K, it's just going to type over it. Okay. So again, though, I need that. I need that right there. Okay, because it needs to be in the list. Oh, you know what? On my last remove, I never actually returned that data. Remember, we got data right here. We got it. We need to go ahead and return it. There we go. All right. So now on the set. Oh, we don't need a loop. We're just going to say e. I'll call it old data is equal to my array bracket index. But remember, my array is of type object, so I need to cast this. Just like that. Cast it as an e. All right, so I've got the old data stored as an e, and I need to change what was there. So array bracket index will now become the new data. We don't need to change size. I just need to return the old data. Perfect. All right, lastly, let's get index of. Public int index of, and it's going to take an object. All right, so what we're going to do is we're going to loop through everything, and we're going to see if they are in fact comparable. I equals 0, I less than size, I plus plus. If obj dot equals array bracket I, then we'll return I. Now, if we make it all the way through the loop and we never found it, we're going to return -1. Okay, so this works because the object class has a dot equals method. So in order for this index of to actually work properly, though, they will have to have, E will be a type that had to have, would have had to have overridden the dot equals method to make that dot equals method really effective. Otherwise, it's basically just checking if they are exactly the same object, not if they are the same value. Okay. All right, this looks good. Let's compile it. And let's go ahead and take a look at the documentation for this. Okay, so we have our generic list. You can see that it's mentioning that it's implementing our interface. We do have these methods. We can click on them. And isn't this cool? It's got all of our information copied from our interface. So you may have noticed that I didn't, in my source code, I don't have all those Java docs here. They're all there in my interface, which is exactly where I want them. They're not clouding it up. I've already written all those descriptions. I'm just implementing them. Pretty neat, huh? It's got all that nice Java documentation, but it doesn't cloud up the source code. All my documentation is right there in the interface, and the interface is what I'm really making public anyway. The interface is what I share with people. I don't want to burden people with my source code. And in fact, in some situations, you want to give someone your interface and not give them your source code at all. Because your interface is a description of how to use your product, not actually giving away your product, okay? All right, let's see what we can do with this. I am going to go ahead and make a generic list. Okay, so it's asking me for the parameter type. So Notice it's got the angle brackets, these little alligators, as I like to call them. So I'm going to put in what I'm going to be storing. This time I'm going to use string, okay? We've done enough numbers. Let's use words here. So I'm going to be storing some strings, and I'm going to add. This is added index, so, well, we'll just try adding at index 0. And I'll add the word hello. All right, let's go ahead and then let's do the second add, and it just takes, I'll say goodbye. We can still inspect this, okay? You can see that we have a size. Oh, something's not working here. We need to go back, and we're missing a size. Did you catch it? Oh, there it is right there. We did not increment up size. That's going to cause problems. All right, we'll try that again. All right, make a new generic list of type string. I will add hello. I'll add to position 0, I'll add goodbye. So, and then I'm going to add, again, this should just add to the back, dog. And if we inspect this, we should see, okay, there's the size 3, there's my array of type objects. I've got goodbye, hello, and dog. Now, these are actually references, just to make it easier for us to understand when using strings. BlueJ does actually put in the character values so you can see them, okay? All right, let's try and add another thing. All right, let's try and add the number 9. Ooh, what happened? Int cannot be converted to java.lang.string. So we had an incompatible type error get thrown. We didn't declare that would happen, but that's, you know, as I mentioned earlier, that this error could happen. So we don't. That's a problem, right? Let's try just new object. Okay. So if you just try and make a generic object, it still doesn't work. It has to be a string. See how that works? So let's go back and let's make it a string. I'm going to call the new string constructor. You know, you can do that. It's kind of not that important, but all right. And so if I inspect that now, I should be able to have it. All right. Goodbye, hello, dog, tree. Super. Okay, so it's working pretty well. If I go here to inherited from object, you can see I do have these things here. We have a toString, but it's not very effective yet. We probably should override our toString and loop through our list so that we have a more meaningful list. Well, I'm going to leave that as an exercise for you to do right now. So why don't you pause the video, and I want you to write a method called toString. It's not in our interface MyList, but it's inherited from the object class, so it's basically automatically in there. All right, let's see how you did. So I ask you to write a method called toString, right? Public string toString. All right, so what I'm going to do is I'm going to make a string str, and I'll make it start with a quote and a square bracket and a quote. All right, should we do square bracket or curly? I like the square. All right, so now what I'm going to do is I'm going to say for int I equals 0, I less than size, I plus plus. I'm going to say str plus equals array bracket I dot toString. So it's going to call the toString of that object. If it's if it is a string, a toString is just itself. But if it was like I don't know, like a geometric shape, like we were storing rectangles or triangles, it might be a description of the sizes of the lengths of the edges or the areas or perimeters or something like that. So I'm going to add its toString plus a comma and a space. All right. Now, The last thing we need to do is take off that last comma in space. So it's going to add, if I have the words the hello, goodbye, it would say hello, comma, space, goodbye, comma, space. So I need to remove those. But here's a little trick. If there is an empty list, we would actually get a string index out of bounds exception if we try and remove the last two characters, because there's only one character, and that's that square bracket, if the list was of size 0. So we just need to make sure of that. So I'm going to say if size is greater than 0, which ideally it should be, but we don't want to throw an exception just because they're trying to do a toString on an empty list. Maybe they don't know that it's empty. All right, so if the size is greater than 0, that means we did have some things in it, which means that no matter how many items in our list, we do have a space and a comma at the end that we don't need. So I'm going to say str equals str.substring from 0 to str.length minus 2. And that's how you just chop off the last two letters. So 0 is the first character of the length of the string minus 2 will chop off the last two letters. And finally, we'll just return that string plus that extra little closing bracket. And now we have a more effective toString. Let's take a look. So again, I'll make a list. I'm going to make this one of type double, okay, just so we have to see how that would work. Okay, so I'm going to add 9.8. Now, this is going to be automatically put in as the instance of the double class. So when I type in a number like 8, we're going to get a problem because it's going to say int cannot be converted to double. You would think that it would be able to, but it cannot cast and convert to object, the wrapper object, in one step. That's not allowed. So because I have 8, Java could make it into a primitive double because double is wider than int, right? We just add 0.0, but it can't do both at the same time. It can't add a 0.0 and then make that into an object double. And so that's just an important thing to keep in mind there, that when you are dealing with objects in a list, like wrapper objects, like the integer class or the double class, you need to make sure that you actually type in the 0.0s and check for that. All right, let's run our toString that's inherited from object. Boom. That's nice, isn't it? Okay. So this is working pretty neat. Let me run that one more time because I want to check some more methods. We have a negative 9.3 in index 2, but let me add another number. Let me add 99.1. All right. So I'm going to go ahead and I'm going to find the index of 9.3. Negative 1. Did I not remember it correctly? Oh, it's a negative 9.3. Well, we know it works when there's not one there, huh? That's good. So let's get negative 9.3. Boom. It returned an index of 2. Let's take a look at it. Let me inspect it this time. Inspect it, and okay, look, you can see here the doubles are really showing the true thing, that these are actually pointers, because remember, an object is a reference item. So it's saying that at index 2, this reference should be to an object that is a double, and you can see that the double object just contains a double field of the number. So it's it's just one extra little step there, but that's perfect. It showed that it worked. Let's remove it. Let's remove the item at index 2. All right, it returned to us a value. That was that old number. And let's call the toString on it. It's gone. Neat, huh? And those are objects. Those are generics. They allow us to store different objects. I want us to make a quick class. Let's make a new class, and let's call it dog. All right. And I am not going to add much to this class. Public class dog. and I'm going to make private string name and private int age. Okay, and so we're just doing this to check that we can store dogs on our list. So the name gets in and the age gets the A, and then we're going to say public string get name. All right, and we'll return the name. Public int get age. We'll return the age, and I'm not going to make it to where we can change those values. They're set. It's an immutable. But let's override the toString for this class. So we'll say public string toString. I'm going to say return bark. My name is, and we'll put the name. And maybe you could also have it yell out or its name, or maybe its age, or you could even have the dog maybe bark using the loop. You could add to the string, make it bark the number of times of its age. That would be kind of fun, right? Let's see here. But I think I'll just stop with that. We're just trying to prove the case here. One other thing I'm going to do is I'm going to override the equals. So public boolean equals, and it takes in an object, and I'm going to say if obj is an instance of dog, and, well, that's fine, I'll just do that. Then I'm going to say string in equals, I have to cast the object as a dog, dog other equals casted as a dog. Remember, we checked that it was an instance of dog, so we know that this is safe. And then I will return other dot name dot equals this dog's name. You could say this dot name. We're checking if this dog equals the obj dog, but this is implied, so just say name. And other dot age is it's an int, so I use equals this dog's age. Else, well, if it wasn't a dog, say it was a cat, well, then they're not the same, so we'll just return false. All right, that's a pretty complete class. Am I missing a closing bracket for the class, though? Yeah, I think I am. Okay, so I like it. Let's give it a try. Let's see if we can't store some dogs. So I'm going to make a list of type dog, and let's add some dogs. I'm going to, let's make some dogs here. We're going to make a dog of Sparky, right? Sparky. Sparky is 3. And then I've got a dog named Solomon. And who knows? I think he's like 4 or 5. I'll say 4. He's young at heart, whatever. And then I've got another dog named Bailey. Is that how you spell Bailey? Yeah, I think there's an E in there. What do y'all think? Yeah. All right. Bailey is a 3. Okay. And then I'm going to, well, let's add one more. I had a dog named Lacey when I was growing up, and I loved that dog so much. I'll say 12. She lived a good long time. All right. Perfect. I got 4 dogs here. I'm going to make, I got a list here of type dog, right? Size 0. Let's add a dog. I'm going to add that one. You just click on your workbench, right? Add dog 1. Boom. Let's add another dog. Dog 2. Boom. I'm going to add at index. I'm going to add at index 0. I'm going to add dog 3. Oops. Add at index 0. I'm going to add dog 3. Right? And you can see you have past stuff there. Okay. And then I'm going to add one more time. I'm going to go ahead and add dog 4. Okay. And let's take a look. Well, let's call the toString. Bark, my name is Bailey. Bark, my name is Sparky. Bark, my name is Solomon. Bark, my name is Lacey. Neat, right? Okay, so that's working pretty good. It's called the toString on each one of those. Let's inspect it. Okay, so we have an array, and it's pointing to, it's got different references, right? And those references are to dogs, and each dog has a name and an age, as you can see there. They are private. Remember, BlueJay's letting me inspect it right now, just because, you know, for debugging purposes and learning purposes. Normally our users would have to call the getter methods. All right, let's go ahead and do one more thing. Let's check and see if we can find the index of dog 3. And it's 0 because we added dog 3 to the front. Remember that? Let's try index of dog 4. Well, that's at index 3. So our generic list is able to hold really anything that we want. So this is a much more powerful data structure, don't you think? Generics, they're so super cool. But you got to make sure you know how to use them. All right, let's take a look at how we would use these generics briefly before we close in a written class, like a project you're working on. So I'm going to make one more class. I'm just going to call this called tester, okay? And this tester class, we're just going to look at how to use our list. Public class tester. And I'm just going to make public void. I'll just call this method test. That's fine. All right, I'm actually going to make this method static so I can call it directly. I don't have to make an instance of the class. So that's, if I leave the method not static, then I have to create an instance of the class and then right click on it down here. But by putting the word static, you'll notice that like dog has new dog constructor, that static method will appear here. So that'll actually be a little more convenient. Cuts, you know, 2-3 mouse clicks off, I guess. All right, so let's make a list. I'm going to type it as my interface to show you that I can. My list is going to be of type, we'll just use string again, I guess. Type string. So I put string in there. And it's going to be called list1. Now, I type it as the interface. I could also say generic list there as well. But we're going to learn that we can make lists in multiple ways, and it's good habit to type it as the behavior. Remember, an abstract data structure is described by its behavior. Well, it behaves my list, and I instantiate it with my choice of how it was made. Well, this one I'm calling generic list. I could have another kind of thing. This one's an array list. I could use a linked list or some other linked data structure, or maybe a data structure that keeps it alphabetized. We didn't say that that it had to be one way. I guess you wouldn't use alphabetized when we have index of, but you know, setting indices. But we'll see how that kind of thing can work out. So this will be a new generic list, and I used to, you had to say it both places, right? If you like being explicit, then you can do that, but it will infer it, and you can just leave that blank. It reads it from here and puts it there. So and then I'm going to say list1.add. I'll add the numbers 9. List1.add -3. List1.add. Oh, these are supposed to be strings. Here I am adding integers. Well, how about that? I'll make my 9 a string. This one here, I'll make it Jed. This one here, I'll make it hero. List1.add link. All right, let's make another list. Well, let's print this one though. System.out.println. Let's print out our list1. And let's add some more stuff. Let's get another one. My list. This time I'm going to make it of type integer. And I can put stuff in there, right? List2.add 9. List2.add 3. List2.add 5. List2.remove index 0. Just so you can see how we do that. And let's do list2.add 19, 24. That's going to be, I'm going to add a couple more because I don't know if we've checked out expanding to make sure that our expand works. So we'll go ahead and do that. There we go. And then let's print that one out. All right, let's give it a try. So I've got a little tester here, and I'm going to run it. So notice I can create an instance of the class, but because I have a static method, I just get to directly run it. Boom, pretty much works the way we want. So just to review, again, that's how you use these things. You can create them by saying the name of the class that implemented that interface, but if you're using an interface, it's best to type it as such. And, you know, just call the methods that are available, practice them on your workbench, and then, you know, put them to work in your programs. And being able to solve lots of puzzles, lists that you can add and remove can really help you solve a lot of problems. All right, well, that's it for now. On the next lesson, we're going to look at how to utilize some of the pre-built collection stuff from Java, how to use their stuff, and how to subclass it and use their interfaces to make really powerful lists really quickly.